All right, thank you so much for being here. First of all, just quick thanks to all the sponsors. Without them, we wouldn't be here. So thanks again. So my name is Pablo. I'm from here, Dublin, Ireland. So it's the first time that I don't need to submit for approval going to a Salesforce conference. So I'm very happy to be here. And I'm going to be talking about modularity, coupling, and cohesion, which is kind of the holy trinity of Apex. So that is the outline. It's very short, but so let me give you some history of how I ended up doing this session. So about a year ago, I had the idea of writing a book on clean Apex code. There are other books on clean code, but there isn't one for Salesforce developers or that deals with the constraints of development in Apex. I also don't agree with some of the stuff in the books that are written, so I wanted to write my own thing with my own perception and my own experiences. And so this is just a screenshot from a year ago where I basically asked on my LinkedIn network, hey, should I write this book? Most people said yes. Some people said no, but I wrote it anyway. So I want to thank these 8 guys. So I had a lot of people that helped me throughout the journey of writing the book. Some people came and went, but these 8 guys really stayed with me until the end. They were super helpful in making sure that my arguments made sense, that that what I was saying was correct and all that. And so I couldn't have written this book without them. And so it was like 10 months of continuous effort and a lot of hours after work and during the weekends. So I'm incredibly grateful to these individuals. And so after a year of work, I can finally show the book cover of Clean Apex Code Software Designed for Salesforce Developers. So I'm very happy that the book is coming out soon. It should be available for purchase maybe May or June this year. And so this is the table of contents of the book. And today's session is basically a summary of chapter 10, which is about modularity, coupling, and cohesion. I need to warn you that it's a little hard to take each chapter from a book and make it, friendly for presentation. Just because by the time you get to chapter 10, as you can see, I've gone through a lot of stuff that, well, chapter 10 assumes that you know those things. And I cannot assume that you know those things here, and I don't have time to go through, chapters 1 and 9. So I did my best to, shorten the amount of information, but it's not the same as reading the book. So buy the book, please, when it comes out. All right, so let's talk first about the concept of deep modules. And as I said, bear with me if it's not too clear, things will make sense. If it was written medium, it will be a little bit easier. Right, so I'm sure all of you have heard the common conventional wisdom around, methods. They should be short, they should do one thing, they should be well written. Who's heard about this type of stuff, right? Most of us. This is what we all learn from blog posts, books, etc. And so I'll give you an example of a very simple method, right? We all know the limits class in Apex that allows us to understand how many limits have been consumed in an Apex transaction. Now, what do you think happens behind the scenes when Salesforce is doing this? It's probably a lot of stuff, right? They're probably tracking that the transaction started. They're tracking that you are queuing some Apex classes for later execution. They're tracking how many of them you're queuing, and then they're later probably kind of tracking that the transaction stopped, right? And so what if Salesforce had provided us, instead of this API? I'm not saying it's good, by the way. I just want you to think, what if Salesforce had said, well, if you want to track limits in Apex, here's what you have to do. You have to start a transaction. You have to specify the limit you want to track using an enum. You want to start tracking, then you start doing your code, and then you stop, and then you get the remaining. I'm sure you see this, and this feels wrong, right? Like, there's no way you want to do this versus that, right? If you can just do this, it's much better than doing that. However, there's nothing wrong with this code, right? The methods have good names, right? They are probably short. They have a single responsibility, right? Start transaction, very clear. Start tracking. So why does it feel wrong? How come these methods apparently follow all the design principles that we've learned, yet there's something here, right, that feels like I don't want to use that. I want to use this. This is much better. So can somebody think what's wrong with this? Exposing the complexity. That's one thing. What else? Convenient. Sorry? It's inconvenient. So it's complex. You have to think of all the little moving parts. You have to remember all the methods. You have to remember the order in which they need to be used, right? If you put one before the other one, then something is not going to work. And it just introduces too much code, right? Just too much boilerplate that just really wasn't needed. And so I want to introduce the concept of a shallow module versus a deep module. And so what you saw here is what is known as a shallow module. So a shallow module is, and a module could be a class, could be a method, could be a collection of classes. It's just a overarching group of functionality. A shallow module provides very little functionality, but exposes too much complexity. So we look at this, every method does very little, just one piece of the problem, but the module as a whole exposes too much complexity for us. Like, we don't want to deal with this complexity. And as I said, each method doesn't really work, doesn't do anything. It's just, it solves half the problem, whereas this solves the whole problem. Very simple interface. We don't need to think about it, but the whole problem is solved in one go. And so a shallow module, again, provides a complex interface. By interface, I don't mean like the traditional interface of object-oriented programming. I mean what it presents itself to us. It's complex, but every module provides very little value. Whereas a deep module is a very simple interface, very simple for us to understand, but the value that it provides is very, very deep. There's a lot of things that we can do with it. Now, again, if you see the comparison, somebody may say, well, I have all these methods, clearly defined, good names, good responsibilities, but it's just too much complexity for the user to deal with, and all of them solve half the problem, whereas this solves the problem completely. Now you would think, Pablo, come on, that's a pedantic example. Salesforce wouldn't do that, right? That's just you making an artificial argument. But they have done this for the HTTP, how you send an HTTP request in Apex. You have two classes, the HTTP request and then the HTTP. And they actually cannot do anything without the other. If you just create the HTTP request, there's no way for you to send it. And if you just create the HTTP, there's no way for you to send anything without a request. So in the .NET programming language, actually this thing is combined into one module. There's the simple HTTP send, done. But Salesforce broke this into two, which normally feels good, right? It's single responsibility, clear separation of concerns, etc. But they are shallow because they don't really solve the problem. They solve half of the problem. And for us as the developers using this, again, we need to remember, which one do I instantiate first? Where is the send method? Was the send method on the request or was it on the HTTP? So even though the modules conform to traditional wisdom of separation of concerns and all that stuff, they're a bit shallow and they introduce complexity for us to deal with. Now, but methods should be short, right? So how do we balance this idea of short methods versus going deep and solving the problem completely? Well, so there's a difference between internal methods and a public API, right? So your internal methods, it's okay for them to be short, right? But it's okay for them to do one thing, to be very small. But for the public API, meaning what you expose to users, make sure that they provide a lot of value with the simplest interface possible. And that means that your public methods are essentially deep modules, and it's okay for the internal ones to be very small, very focused, and that don't solve the problem completely. So the idea here is that we need to think when we are writing code, there are two people we're writing the code for. We're writing it for ourselves, but also the people that are going to use it. So when we think about ourselves, we do need to break things down so that we can manage that complexity. But for the people that are going to use it, we need to provide them the highest value possible with the simplest interface. Now, quick exercise. So if we agree that private methods should be short, then that naturally means that private methods should be broken down into smaller methods, right? So you would have a longer private method, and then you realize it's too long. I'm going to break it down into smaller methods so that it's easier to manage. But then how do you know? Where do you make that cut? Right? So if you have a method, internal method that is this long, do you cut it here? Do you cut it here? Do you take 3 pieces? Do you just cut it in half? How do you know? And so I'll tell you what a red flag is. If you break down a method in, let's say, 2, and you find yourself going back and forth between both of them, that means you broke it down at the wrong point. So let me show you an image. You have this long internal method. You break it down into 2, the parent method and the child method. And so how many of us have had this experience of looking at 2 methods and just doing this? Okay, pass the test parameter. And where does this parameter come from? Oh, comes from here. And this. And so that back and forth, has anyone experienced it? Right? And so what that is, it's your brain trying to compensate for that split, and it's your brain wishing that they were just one. That's what your brain is trying to do. Your brain is trying to imagine, I wish this was just one method so that I could visualize it in one go. And so if you have to do that back and forth, that means that you broke it down at the wrong point. And so the guidance that I would give, how do you know when to split a method, is try to think of a subtask, right? If this method is doing this many things, is there anything that I can take out of here that is a bit more somewhat general purpose? That is not that I'm just taking a piece of functionality randomly, but that I can think of this as a subtask that can be understood on its own. And that ideally could be reused within the class. Now, I argue that we shouldn't be too afraid of a long method, longer, not long, if it makes it easier to understand the entire process in one go, and if it reduces the surface area for future changes. Now, please don't leave this session saying, oh, Pablo is saying we should use long methods full of anti-patterns. That's not what I'm saying. I'm saying that if you have a bit of long method, just think a bit more, right? Should we just split it because that's what we've been taught? Or if we split it, are we adding additional complexity that wasn't there? And I'll touch on this a bit later because I'll give specific guidelines about when it makes sense to break things apart and when not to. But I argue that we shouldn't be afraid of a long method. I'm not going to say how many lines because that's debatable. It could be 20, 30, 50. It doesn't matter. It depends, right? Now, so that's the concept of deep versus shallow modules. So now we can talk about modularity. So modularity is the degree to which systems component can be separated and recombined to achieve different things, right? So if classes focus on different responsibilities, it's easy for us to combine them and work in different ways. So there are different principles that support modularity, right? You have the single responsibility principle, you have information hiding, you have encapsulation, do one thing, abstraction. You have all these things that we've learned that support this concept of modularity. But I found that it's very hard for us to actually articulate why do we need modularity. We often get too caught up on the principles and we say, oh, we should follow the single responsibility or we should encapsulate, but why? So I encourage you to think, why did Robert C. Martin came up with the single responsibility principle? Why is it important for us to encapsulate things? Why is it important for us to hide information and not expose too much? Is it to abide to those principles? Or is there some higher level overarching reason that this exists? Anyone? Any ideas?
With develop by moving stuff into modules, you're adding the complexities so you can understand.
We got it right there. It's complexity. So if the code base is modular, then we as developers only need to face that complexity in small chunks, right? So if your code base is super large and everything is like, a big ball of mud, very hard to understand where one thing ends and another one stops, you need to face that complexity all the time. Even for a small change like this, you have to understand the whole. And that's just very, very hard. But if things are modular, if they're broken down into smaller things, then we can face that complexity in small chunks. I just need to look at this thing. If I understand this thing, I can make the change here, and I don't care about whatever else is going on around it. So I really encourage you to think of of modularity as a means to an end. The end is not modularity on its own. Modularity is a means to an end, and that end is to reduce the complexity that we have to face at any given time. Now, we're talking about separating things, right? Breaking them down. And I touched on this earlier, but one of the hardest questions to answer is if you have two behaviors or two pieces of functionality, how do you know if they should be separated or if they should stay together? It's not simple, right? Again, we may think, well, the methods should be short, they should be single responsibility, but it's not always clear if I should keep something together or if I should separate them into different modules. So again, this example, if you have this, how do you know, should I just keep it like that? Maybe it's okay because I can understand everything in one go, or should I separate it? And so if we argue that the goal of modularity is to reduce complexity, then we can argue that the best way to determine if things should be apart or together is if that split reduces or increases complexity, right? So when you have something and you say, I'm going to split it in 3 parts, did that increase complexity or did it reduce it? And so I don't think we as developers think a lot about these things, right? We're always thinking about just they should be short because that's what I learned and they should be easy to test. But we're not really thinking that those are all means to an end and that end is reduced complexity. So again, when you're breaking something down or when you're considering taking something and making it apart, our driving desire should be to reduce complexity and not to increase it. And so unfortunately, that sometimes means that a longer method is simpler to understand because you can understand everything in one go. Sometimes a longer method does need to be broken down into smaller methods because if you break it down, then the complexity is reduced. It really depends, but what I really want you to think about is don't just follow these guidelines just because they've been written somewhere because that's what you learn. Think, am I reducing complexity or am I increasing it? So there are actually some negative consequences of breaking something down into too many small pieces. And so, for example, the more modules, if you break it down too much, where everything is just very tiny piece of functionality, then it may increase complexity because you basically have a lot of shallow modules that don't really do anything unless you know how to put them together. And so it's hard to understand who does what, and even namings might be hard. Like if you have too many classes for a single domain, how you give them a good name eventually starts becoming hard because you're just trying to artificially separate them. If you oversplit something that was together, then you need code to make it work together, right? So if something like this worked fine and now it's 3 parts, you need additional code to make those 3 parts work together, and that code did not exist before. You didn't need that code before because it was all in one chunk. Also, something that I'll talk about at the end of the session is cohesion, is that separating modules can make them feel disconnected, and it may not be obvious that they're actually related or that they share some fundamental concepts. And finally, if you split things too much, you may introduce duplication because some logic that was in one place now needs to be in 3 different places. And then you may say, well, but I can just extract that logic into a separate module, but now you have 4 things that are coupled. Whereas before you only had 1. That was just a bit bigger. So that's, negative consequences of splitting things too much, but there are other reasons where you should consider keeping things together. So for example, if they're always used together and they share the same information, they share the same protocols, and they depend on each other, then maybe they should be one. Again, I give the example of this because I've always found it weird that I have to create two classes for this when in languages like .NET or even JavaScript, I just need to use one thing and that's it. Another reason is that they serve the same or similar purpose. It makes sense to keep them closely together. And that's, again, cohesion. We'll talk about that later. But if you think of the delete white space and ends with methods of the string class, they're totally different, but they serve more or less the same functionality regarding string manipulation. So it makes sense for them to be in the same class. And finally, if you have two modules, but understanding one requires you to understand the other, like one doesn't make sense without the other, then again, maybe they should just be one, because then you can understand one without that back and forth. Now, the other important piece is understanding what are the properties of good modular software. So I have this example where we have three modules interacting together. We have the date module, database, and system. Very simple, right? Three different modules working together to achieve something. And so I want you to pay attention to the second line where we make the process date equals to date. Now, what if instead of this, you saw this? What if the date class had a random method called setField to today? Just like the example earlier, I'm sure this feels wrong, right? You look at this and you're like, that's just weird, right? But again, it's not clear why it's weird because it has a good name, right? It belongs to the date class. It makes sense. It's short. It's easy to test. Why does it feel wrong? Right? So am I the only one who thinks this feels wrong? I'm sure for others this feels weird, right? You look at it and you're like, there's no way the date class would have a method to specifically set a field to today. So any ideas on what's wrong with this?
Because it's too much double field. The date class is suddenly out about days, right? But where of the field, so when is it field is the one.
Okay, great. That's one reason. Yeah, so it's too coupled to the idea of a field, or it has too much knowledge that that users may want to put a field to today's date. That is 100% one reason. Another reason is that it's too specific. It's too special purpose. It is so narrow in its use case that if you have that, you would also expect to have this. Set field to yesterday, set field to some specific date. Is this field date in the future? Is it in the past? Right? The moment you introduce something so special purpose, it creates inertia for you to create more very special purpose modules. And here's where things get interesting is that general purpose modules are actually deeper, which is kind of, it's not intuitive because if you think of the date method here, date to date doesn't solve a lot of problems. It actually solves a very small problem, which is just give me today's date. But because it's general purpose, it allows you to solve an infinite number of use cases throughout the code base. And ironically, that means that it's actually deeper than having a special purpose code that only serves one specific use case. So this is, again, an example of a shallow module. Again, good name, good functionality, but too specific. So again, something to think about is that general purpose modules are ironically deeper. And I'll give another example of this is I controversially think that selectors are actually shallow modules. And so this is an example of the typical, SQL query selector from Financial Force or other libraries where we create specific methods to query different things, right? So again, it creates that inertia that if you're going to have a query by ID, why not have query by industry and maybe query by specific field, maybe query with all fields or query with only these fields? they become so specific and so special purpose that the whole selector as a whole becomes a shallow module. Why? If we remember, the definition of a shallow module is very high complexity, very little value. Each method just gives me a little value. It's almost like, well, with this query, I can only query that. If I need something else, I need to create another method. Now, I know some of you may be thinking, well, but selectors are needed for mocking the Salesforce database and all that stuff. Well, you could use another library. So this is not my library, so I have no affiliation to this. But here's another library for abstracting SQL queries, which allows you to mock the query. So that's line 4. But anyway, that's not important. What's important here is that this is a general purpose library for doing SQL queries that still allows for mocking. And again, ironically, it's deeper. Why? Because you can use it everywhere. The value that it provides to the entire code base is infinitely higher than very specific or very special purpose methods that may have a one-to-one relationship with a specific class. All right, so let's take a break. So let's talk about coupling. So that was the first part of the session, right? Modularity, deep modules, and general purpose modules are deeper. Now, coupling is the degree of dependence between modules. So how much the modules depend on each other. And I want you to focus on the word degree because coupling exists on a spectrum. It's not like it's either coupled or it's not coupled. It's actually a degree. Is it too coupled, or is it more or less coupled, or is it very loosely coupled? So the typical example of a tight coupling is when you have a class and you have the new operator instantiating another class. So for example, here, custom lead conversion 100% depends on lead conversion util, to the point that you cannot deploy this without deploying the other one, right? They have to be deployed together, or at least lead conversion needs to exist in Salesforce org before you can deploy custom lead conversion. So people love this example and say, oh, look, tightly coupled code, bad. Right? So what do we do? What we've been taught is, well, let's put it behind an interface, right? So now utils is behind this interface lead conversion, and you pass it through dependency injection, and now magically they are decoupled. But somebody else does know about this specific implementation, right? So you still have to pass the specific implementation somewhere. And while this may decouple the classes from a purely metadata level, right? So now they can be deployed independently. They can exist in different packages. That's great. But custom lead conversion expects a class to implement the utils interface, and it expects for that class to actually implement it correctly, right? If that class implements the methods but doesn't really fulfill the requirement, or it makes some nonsense, this class will still be affected. So they're still coupled. They're not coupled at the metadata level, but it still 100% depends on the fact that that class needs to do what it's supposed to do. And so the thing is that coupling can actually be invisible. You may have something like an account trigger handler and Lightning Web Controller, and you could say, oh, those classes have nothing to do with each other, they're completely independent. But then some business requirement changes, and guess what? You have to change both. And so were they coupled? Well, they're not coupled to each other, but they're coupled to a concept. They're coupled to an idea that is present implicitly in both of them, right? And so this is a coupling that is invisible, and that's why I insist that coupling is not like it's not there or it is there. It's a spectrum. And so even when you may not see it, things can be coupled. So one way of finding coupling that is usually invisible is if you see classes that are always changing together, right? So if you look at your, let's say, commit history in Git, and you see that these two classes are always changing together, is because they are coupled to an underlying concept that may be invisible from the, at the metadata level, but they both share that. And so they're still coupled. And again, one could argue, if they're going to be coupled, then why are they actually separate? But again, that's the next topic, which is cohesion. So a few things to remember about coupling. Coupling is not bad. People love saying, things should be loosely coupled, and they should be to some extent, but it's not bad. The irony is that modularity creates coupling. Because if you break things down into smaller things, then they have to work together. How can they not be coupled? They have to be coupled so that they can achieve a higher level purpose. So coupling is not necessarily a bad thing. It's just something that you have to manage. And too much coupling can increase complexity, right? And that's the whole kind of center of this presentation is complexity. If two things being coupled increases complexity, that coupling is bad. If two things are coupled to an idea and maybe that idea never changes, then it's okay that they're coupled. So what if they're coupled? They have to be coupled at some point. So that is not a bad coupling. And again, I argue that loose coupling or loosely coupled code is not a silver bullet. And again, I critique this because I feel like people love saying, look at my dependency injection framework. Now things are decoupled. Nobody knows about each other. They're still coupled at an invisible level that you just can't see. And that arguably sometimes is more dangerous because you have no idea that coupling exists. And that's when we can use cohesion. So cohesion is kind of the opposite force of coupling. So we can use cohesion to balance the negative effects of coupling. Can anyone give me a definition of cohesion? There are actually like 10 definitions, so neither is correct, but I would like to know if anyone has their own ideas as to what cohesion means. Sorry? Keeping things together? Yeah. So there are three. So one is that cohesion is about how well the elements within a module work together to achieve a single purpose. Another definition says that cohesion is a measure on how closely related the items of a module are. And probably the most controversial one, thankfully is not mine, so don't critique me. It's actually from Kent Beck. He says that a module is cohesive if its sub-elements, so the variables, methods of that module, are coupled. And that's such a strange definition, right? How can we say that cohesion is there to balance coupling, yet a module is cohesive if its sub-modules are coupled? Kind of doesn't make sense, right? So let me give you an example. So this is cohesion, let's say, inside the string module. All the methods here, they do different things, single responsibility, all that, but they all work together to achieve a common goal. So one way to understand if something is cohesive is if there's an obvious way to split it apart. So again, if we think of the string class, is there a way that we could separate it into three parts? Is there a meaningful split that we can say, okay, we're going to take the string class, now it's going to be three classes, and it's going to be great? I can't think of any way that I could do that because they're all related. So the module as a whole is cohesive. And so that's one good test. When you look at something, you're like, I really cannot split this anymore. Or if I split it, I will increase complexity. Then that is cohesive. And that's good. But the kind of the real definition, as per me, so if you don't like this one, then you can criticize me, is that cohesion is really a technique to shorten the distance between coupled elements to make that coupling more obvious. So what does that mean? So let's imagine we have this scenario where we have module A, module B. They are supposedly independent, but a submodule, which could be a method or something like that, a submodule of module A depends on a submodule of module B. And module A and B are completely separate. They could even be in different SFDX folders. They have nothing to do with each other. But that little module there depends completely on that. And it depends so much on that it actually cannot do anything without it. And so there's a very long distance between that coupling. It's not obvious, or it may be hard to understand. Again, they may be in different packages. It may create deployment complexities because they are so far from each other. If you were to combine the two modules, A and B, into one bigger module, the submodule is still coupled to that. That coupling didn't go away, but it's a lot more obvious. Now it's there, it's in a single place, and you can see, I can see they're coupled, but it's not coupled to something over there. It's coupled to something that is just next to it. And that's the whole idea of cohesion, that if things are going to be coupled, then at least bring them together as much as you can so that you limit the impact of that coupling and you make it a lot more obvious. So this is not just in Apex code, it's also at the macro level, right? I hope most of us are using SFDX folders to group functionality together. But if you aren't, if you just use the default classes folder where you put all your Apex classes there, you may have classes that are coupled to each other, but they are very far apart, and it's not clear that they're coupled. If you bring a set of features or a set of functionality into its own SFDX folder, then you make that coupling obvious. It didn't go away. It's not less bad. It's just obvious now, and it's a lot easier to manage it. And so, because an image speaks 1,000 words, then I leave you with this. That is the holy trinity of Apex: modularity, coupling, and cohesion. And thank you so much. We're done. I have 3 minutes and 40 seconds for questions. Yes? How much would be my book? It's like 50 euro. It's not up to me, it's the publisher. But yeah, thanks.
As a relief, when you started finished.
I am very relieved to have finished the book because I was getting burned out towards the end and it was very, very hard. So I'm like very pleased that it's done and I cannot wait. Yes? It'll probably be available in June. It's up to the publisher. You can already pre-order it. So if you go to Amazon and you just search for Clean Apex Code, you can pre-order it. It says it'll be available in September, but that's just a placeholder from Amazon. It should be available somewhere in June. And so this QR code is not about the books. This QR code is to give feedback about this session. Any other questions? Yes? I don't know if you can get the slides of this presentation. A lot of this stuff is from the book. So I'm not trying to tell you to buy the book, but maybe buy it. But if you read chapter 10, it has all this stuff plus a lot more explanations that I just couldn't fit in this short time. Okay, I think we're done. Thank you so much. Have a nice day.